Hi guys, welcome back to the coding interview pattern series. This is the fourth video we are going to cover the two heaps pattern. So if the name suggests two heaps mean maintaining the two different heaps. So it is mostly used in the data where we want to divide the data into two parts. We want to find the maximum minimum number, mostly with the computational problem. So what happening is this one, if you go to the decode this pattern, it's saying that you need to maintain the two heap and this now two heap will be such that, suppose if I say this is the minimum heap and this is the maximum heap, so the root of this number, the root of this will be the minimum number and the root of this will be the maximum number. So when you have some data in which one we want to find the minimum and the maximum number after dividing this data into two parts. So let's say I have this much data and I want to divide this in two parts, and from, suppose let's say in this part I want to find the minimum and from this part I want to find the maximum. In such cases we can use this two heaps pattern. Now we are saying the minimum and maximum mostly, but it is not necessary always that there will be one minimum, one maximum. Maybe there will be requirement that hey, you want to maintain the both maximum. You may want to maintain the one minimum, sorry, both minimum. So this is like based on your requirement, your problem, we can use the minimum max, max max, minimum minimum heap. The thing is that property is such that root of the minimum will be the minimum number, root of the maximum heap will be the maximum number. One more thing is, just remember that when we are dividing this data in the two parts, and suppose we have this continuous data, now we are dividing this in two parts, and suppose say we are inserting this some data in the this suppose minimum heap and some data in the maximum heap. It doesn't mean that the number in the maximum heap will be more than or greater than the number from the minimum heap. No, this property is not to be true always. The thing is, the root number from the minimum heap will be the minimum number and the root number from the maximum heap will be the always maximum number within this data. That is the truth. There can be happen that in this one the numbers are bigger and this one numbers are smaller. This can happen in the maximum minimum heap, so that is not guaranteed. Now if from this one the costing part and time complexity part knows something, when we insert this kind of the data in the minimum heap, when we say the heap part, it's mostly take the big of n log n. Okay, sorry, n log, big of log n. Okay, and to achieve the constant data from the root, we can just use using the big of 1, which is the constant time. Now let's understand by some example, or not example, before that we can understand how actually this heap got prepared. How we can prepare, suppose we have some array, I want to prepare the minimum heap, maximum, how to prepare it. That we can understand, then we'll use this to solve the problem. So let's understand now how we can prepare the maximum and minimum heap. So let's say we have this one array. This is the array. Okay. Now from this one we want to prepare the minimum and maximum heap. So how we can prepare it? So let me write again here. I'm just moving from here for the space issue. Okay. So now if you want to prepare the minimum heap and maximum heap for this one, how will prepare it? So let's say first prepare the minimum heap. Now we know that minimum heap will contain the smallest number at the root level. So we'll start from here, we'll have the 10 numbers, so we'll edit the 10 number is here. So this is the become root because only one number is there. This is done. We have 11 number. 11 number is less than, sorry, greater than 10. So we'll put on the below part. So we put the 11 here. So 11 came here. Now 11 is done. we have the 3 number. 3 number is less than the current root number. That means this 10 will be replaced by the new number 3. So I am removing the 10 from here, I am putting 3 here, and I am putting 10 here. Okay, 10 is done. Now it's not like binary subtree where we put all the less number on the right side, left side and big number right side. No, we just need to balance left and right, and it should be such that if I remove this root number, if I remove this one, I can just bring this 10 on up, and again it will become minimum heap. So on this one switch, it will be again become the minimum heap. So this is fine. Now we have the 7 number. Now 7 number is again greater than 3, so root number no need to change it. But if I want to put on the left side, because both are balanced now, the 11 is more than 7, so I need to replace 11. So I need to put 7 here, and I am putting 11 here. Now again I have number 2. 2 is less than 3. That means I need to replace 2 and 3. So I need to I am replacing 3 was there, I am replacing the 2. Now 3 I will put on the left side, but 7 is again greater than 3. 3 is less than 7, so I need to replace 7 with 3. So I am replacing the 3 here, and I am putting the 7 here. Now this is the minimum heap. If you see, the root number is the minimum number from this one. The 2 is the minimum. Second thing is, if I remove this 2 number, I can just bring this 3 up, and again it will become the minimum heap. When I bring up 3 here, 7 will become here. Then if I remove the 3, 7 will become the root number. So it will be always the minimum heap, which will have the minimum number at the root level. So if minimum heap is clear, let's go to the maximum heap. Maximum heap. On the maximum heap, let's start again with the same number. We are just preparing the same maximum heap, minimum heap for the same number. We are not dividing the number for now. So we will say that one number is 10, we will put on the top because only one number is there. We have 11 number. 11 is greater than 10, so we need to replace 10 with 11, and I am putting 10 here on the left side because firstly we prefer to fill the left side. 10 is done, 11 is done. We have number 3. 3 is less than 11, that means we don't have to change. I am putting on this side 3 number. 3 is done. We have number 7. 7 is less than 11, so that means root number no need to change. Both are filled, so I can start from the left side filling. Left side 7 is still less than 10, so I put 7 here. Now again 2 is less than 11, not to change it. Less than 10, I am just putting here. So this 2 is become the maximum heap, minimum heap. If you see the maximum heap, maximum number is the top. If I want to, this is the root, and this is the maximum number. In case if I want to remove this one, in some operations, I need to bring this up. So again, this 11 will come, this 10 will become the maximum number. If I remove this 10 also, I will bring the 7 up, so that it will again become the maximum number. So it will keep maintaining that property that whenever you access the root number, it will be always the maximum number. Now this 2 heap patterns can be used in the continuous data also. So let's take example, one live streaming data is there. From that live streaming data, we need to find the median of the data at each insert. So let's say this live streaming is coming, okay, from this one the data is coming on, and this from this one, we need to find the median at each insertion. Okay, so for that obviously we need to maintain the minimum and maximum heap. So let's put this here on this one. The streaming is coming here, and this is our result. Okay, so we prepare the minimum heap and we'll prepare the maximum heap. Okay, so let's just stream first data came as the 10. Okay, so 10, we'll start with the maximum heap, we'll put the 10 here. Okay, the next data came as let's say 14. We'll put on the minimum heap, maximum we already have, we'll put the 14 here. Now at this stage, once we have the two data, if you want to find the median of this number, you know how to find the median of the two number. I mean the numbers are even number. If I say the range, it's even number. Even number median, we need to do the sum of these two both. 10 plus 14 divided by 2, which is 10 plus 14, 24 divided by 2 is the 12. So the median is the 12. Now let's say one more data here. Let's become 13. Now 13 is more than maximum heap, so I am putting on the minimum heap. 13 minimum heap, it is less than the 14, so I need to replace it. So I am putting here 13 and I am taking the 14 down. Now at this stage, if you find to median, it is the odd number because 3 numbers are the total. In this one, we will take the root from the minimum heap. So in this, median become the 13. Correct. Let's say one more data came, and let's get this is the 5. This time 2 number is there, we'll put 1 number on the maximum heap. Maximum heap 5 is less than 10, so we'll put to the down. Correct. Now this is the maximum number, this is the minimum number. We want to find the median number. We have this even numbers, so we will take the average of the two. So we will take average of the 13 plus 10, it is 23 divided by 2, we need to do divided by 2, which will be 11.5. 11.5 is the median number of this one. So like that we just keep continuing this one. This kind of operations where we need to find something or compute something from the live streaming data, we can use this minimum heap, maximum heap in the problem solving things. Now, so this is how it works. This was the like finding the median we can find using this one. So let's take one more example where we'll see that how we can solve some little complex problem, and for that we will do some coding also. So let's move to the next problem. Okay, so we will take the example of let's say one investor is there who want to invest in some project and where he gets some profit. Now, but due to the time limit, he cannot invest in all the project. One is time limit, another is the initial capital. Because to complete each project, he needs some initial capital. So with the two constraints, he want to achieve the maximum profit. So here, see, remember, minimum capital, he want to achieve the maximum profit. Minimum, maximum, two words. We can use the minimum, maximum heap here. Now what he want to, let's understand the problem. So he had some initial capital, let's say 1, 2, 2 and 3, and corresponding, okay, so this is not initial capital, sorry. So this is the capital to complete the project, and let's say 2, 4, 6 and 8. So these are the profits and the capital requirement. So this is the first project, second project, third project and fourth project. Total 4 projects are there. If he complete this first project, he will get the 2 profits, but he need to have initial 1 capital. To complete the second project, he need to have the 2 capital requirement, and he will get the 4 profit. Same thing if I say this last, he need to have 3 initial capital, and then he can get the 8 profit. Now his constraint is there, his initial capital is only 1. So I see initial capital, or you can see 1, and he can complete only 2 projects. So thing is, he has the data, each project, how much profit he will get, and how much cost he need to have, how much capital he need to have to complete the project. which is considered that in his hand only he has the one capital and he can complete maximum 2 projects. Now we need to help him to find the 2 projects so that he can have the maximum profit. So here what we consider is, just one thing in mind, keep in mind that to complete this first project he needs to initial 1 capital, but once he completes this project he will have the total 1 plus 2 is equal to 3 capital in hand, which he can utilize for the next project. Okay, so suppose he complete this one, initial capital was suppose 3. After he complete the capital, so project he will have the 11 capital ready to take the next project. So we'll keep adding the capital. By keeping this in mind, let's continue it. Now as we said, we want to do or achieve the more profits by less capital, means minimum capital. So when we say minimum capital, we will prepare the minimum heap for the capital, because capital is the first requirement. So let's prepare the minimum heap. I said minimum heap, or you can say it is also capital. Okay. Now if I prepare this one, if you put the 1 on top, because this is minimum heap, I am taking first. If I take the 2 is greater than 1, so I can put here left side, because minimum should always stay on the top. Again 2 I am putting on the right side to balance it, and the 3 I am putting on the left side. That means our minimum heap is ready. The minimum number is on the top. Now what we will do is, we'll keep this initial capital in mind. So this at the first time, this is the capital, or you can say initial capital, but once one project is completed, this will be the new capital. It will not be always 1, it will be incremental, or new profit will be added to that capital. Now what we will do is, we say our current capital. So our current capital is equal to initial capital, which is the 1, enough now 1 is there. So our current capital is 1, because we are just going to start the project. Now we will, in this minimum heap, we will check that which project I can do with this 1 capital, current capital. So if I go with minimum heap, I know that top will be minimum. So if I can compete with that, I can try other one. So if I take the 1 corresponding, I can have the 2 profit. So now I will prepare the maximum heap. We can say profit. Why maximum heap? Because we want to achieve the maximum profit with that minimum capital. So this heap is the maximum heap. Now we will check for each. We have the current capital 1. I can say how many projects I can do with the current capital. So I will take the minimum heap from 1. So I am saying this for 1. I can do project 2. So I am putting the 2 is the profit in this one. Correct? Now I have already used the 1. If I remove this 1, what will happen? This 2 will come on the top. Let me take not this 2. So 1 was there, 2 was there, 2 was there, and 3 was there. Correct? Okay. So if I take the 2, this 2 will come on the top, and again it will rebalance it. But this 2 is more than 1. That means it doesn't satisfy the current capital. So I have to, at this top, I have to stop it. I have to take the current maximum profit. What is the current maximum profit? Which is the 2. So I have completed the project 1, which is the completed project. I have completed 1 project. My initial capital was 1. I have earned the 2 more, which is maximum. And at this stage, my current capital becomes 3. Correct? So I am saying, okay, 3 is my become current capital. I am putting this, and 1 project I have used the 1 capital, this project, and I am just rebalancing this. So this is my new minimum heap. Now my current capital is 3. I have already used this also. So now what I will do is, So we cannot do the same project again. Okay, just remember this one. Once this is completed, that means this will not come in the part. So this will also not come in this one. Maximum heap also. Now I have the capital 3. For now, I need to check it with this capital 3. The current capital become 3. Which project I can take it so I can achieve the maximum profit. So if I go with the minimum heap, okay, 2 is less than or equal to 3. That means I can do this project, which is this one. So for this profit is 4, so I am putting the profit 4 in the maximum heap. Okay, I am rebalancing the tree. It's become 2 again. This 2 has the profit 6. So I am putting the 6 here. But sorry, I need to rebalance it because maximum heap is there. So I am putting 6 here and I am putting 4 here. So this is done. I am rebalancing this one. I have just 2 also I have done. So only 3 left. 3 is again less than equal to 3. So I can take this project also. For this one, the profit is 8. If I want to insert 8, I have to rebalance it. So I am rebalancing this one also. I am putting 8 here and I am putting 6 here. So this becomes maximum heap. I have done this all with minimum heap iteration. Now I can check what is the maximum from current heap. What is the current root of the maximum heap, which is 8. That means I can earn 8 profit. Now what was the current last capital? 3 plus 8, total 11. I have completed the second project, which is the project number 4. You can say 4 number and this is 1 number. So at this position, my total capital, I can say total capital is 11. If I want to abstract the pure profit, only profit, that means 10 minus initial capital, not 10. 11 minus initial capital means 11 minus 1, which is the 10. Depend on the what has been asked. It is asked that just return the final total capital or only profit. You can calculate and return it. But this is how you can solve the problem of earning maximum profit with limited capital and limited the project size. Now what we need to do it, like this was solved out, what are the steps we need to follow it, that is important here. So let's see what step we need to follow it. So first of all, whatever I have given it, just prepare the minimum heap. I am just removing this also to edit. So what we'll do is, this problem comes, first prepare minimum heap. Again, preparing minimum heap, this is specific to this problem. In some cases it can be maximum heap, some cases we to heap need to prepare it. But I am listing out the steps for this problem. Once you have prepared the minimum heap, you can start for the each minimum or the initial cost first and prepare the maximum heap. So by keeping the capital. So this is the current capital. So initial capital, then to become increasing capital, prepare the maximum heap. Maximum heap will be from the profit one. And then once you have prepared this maximum heap, take the root of maximum heap, because that will be your the profit, maximum profit you can achieve at this stage. In this one, the initial profit and number of project, how much we can do it, we need to keep in mind when we do the coding. So if this is clear, let's move on to the coding part. We'll meet in Eclipse. We'll try to implement this problem solution and see how we can do it. So let's dive into Eclipse. Okay, we are back to Eclipse. Let's create one class file for this one. The class name should be maximize capital. Okay,
So we have this maximize capital, some main methods already created. We don't need to use that of now, but we'll say we'll create one method which will give us what will give. We are giving the number, so integer, and what we need is get maximum capital. So as I said in the video, if it is asked to return the capital, it is return the capital. If in some case, if it is asked to return only profit, then you can just deduct the initial profit, so initial capital from the final maximum capital and return it. So in our case, we will go with the maximum capital. What we needed, as we said in the video, we need the initial capital. So we need initial capital. We need the number of project he can do it. So number of project, let's take it K. Then we need array, two array. One will say capital and other one will say profit. Okay, so this will be input data, and based on that we need to return the maximum capital. So let's define here max capital is equal to 0, and let's return it, so the error will go away. Okay, fine. So we have this method ready, and we need to implement our method here. So now as we need to follow the steps, what we'll say it that for first we need to create the minimum heap of capital for the capital. So we'll create the minimum heap for capital. Now if we say in the simple word, what is the minimum heap? It is sorted array. Now if we simply sort this capital array, it will create problem because we will lose the corresponding profit mapping, because at the first index of the capitals array it has the capital, and corresponding at the first index of the profit it has the profit. So we cannot sort any array simply, else we'll lose the index. So what we will do is we will just sort this capital arrays, but we will keep track of the index of that capital, and to do that we will use the priority queue. So let's define the priority queue, and we will this is again integer array. Why we are taking integer array? Because we want to save both. First we want to save the capital, plus we want to save the corresponding index also. So this is the minimum heap. We can consider it to make it easy to remember. We can say capital minimum heap. Okay, good. New priority queue. Okay, so we have the capital minimum heap ready. What we'll do now, we will, once we have this ready, so it's like again we have not ready, we just defined the variable. We need to create the minimum heap. So for that we will do this for all the capitals, but we will not use the for each loop because we need the index also. So we'll start with the integer 0, I less than capitals dot length and I plus plus. So for now we are simply preparing the capital minimum heap. Now we offer this one, let's say we offer integer and array, integer, we offer the new integer array, and in this one what we will offer it is first value we are saying the capitals, the actual value, so capital value of at that index, and second we are saying the index itself. So this will insert the capital value and the index of that value. But see, we have defined only priority queue. If it is simply defined priority queue, it won't be sorted, it won't be actual minimum heap. To have the actual minimum heap, we need to keep sorting this. We need to tell that this priority queue that hey, whatever data I am inserting, please sort this according to this one. So what we need to do for that is we need to tell that hey, suppose you have the two element or two number or two object, you need to sort based on this custom sorting. Now what we are saying is that hey, we want to sort in the ascending order because we want minimum heap. So we'll say A0 minus B0. Now what it will do it will sort this whatever we are offering the current minimum heap based on the first value of the array. And what is the first value of this array is the actual capital. So whenever it's sorted based on the capital, the I index corresponding index will be saved still. So we will know that hey, even if the array is sorted, we know that the first value in this minimum heap, what is the corresponding index, and based on that index we will be able to get the profit if needed it. So this is clear. Then let's move it. Now first step we have done with this one. We said okay, we have prepared the minimum heap, capital minimum heap. Now we have the max capital, we have initial capital. Now we said we will have the one current capital, which will be keep changing it, but first time this will be nothing but initial capital. So we have the current capital now. Now what we need to do it? We need to go with the maximum heap. Prepare max heap. Now max heap, no, it will be prepared for each project or each it's kind of like each project we are doing it, for that will be prepared, and we need to keep updating the current capital also. Now we can just let's define it again. Maximum heap also we will use the priority queue because we want sorted things. Here also we will use the array only. So let's say priority queue integer array, and this will say the profit max heap. Profit max heap, new priority queue. Now like we sorted the minimum heap based on what? Based on the first value, but we sorted in the ascending order because it was the minimum heap. Now this is the maximum heap, so the sorting will be reverse. So we are saying if we get the two elements A and B, here A and B are array, then we are saying this time do the B first and then minus first value of the A. So it will be on the reverse order. Reverse order, I mean reverse order compared to the minimum heap. Okay, so what we are missing here is we are saying priority queue, priority maximum, priority queue integer. Oh, I think one bracket is missing. We are doing B0 minus A0. Okay, so this is the profit max heap also ready. Now what we will do, we will go till the project. For all the project we will go with this, iterate it, because as I said, now for each project we need to start with the current capital, and we need to find which project we can do so that we can achieve the maximum profit. So let's say we are starting with I equal to 0, and we are saying we'll complete all the project I less than k, means for all the project we will do these things. Okay, now for each project, remember what we did. We tried to create the profit max heap. We tried to insert the data in the profit max heap. So, and we say, if you remember, we were checking that we will do these things till our current capital is less than or equal, or the capital of this whatever we are getting from the capitals array, which is less than or equal to current capital. I mean, like within that capital, whichever project can be done, we will compare all the projects, and then after that we will take the maximum profit project. So here we need to go through the capital, but we need to see now when we go with to capital, we need to go with the minimum heap because we need to start with the minimum capital. So we are saying till when this is not empty, because this is the first condition. If it should empty, then we should stop it. And n current capital dot pick, it will take the top element or say root element, and then we will say what is the value of the 0 index. Why we are taking 0 index? because in the current minimum heap we have the array of size 2 as per this one. As the 0th index it is actual capital, at the first index it is the just index of that array. So actual capital value lies on the 0th index. So that's why we are comparing the 0th index. And then we are checking less than or equal to current capital. Okay. So we are saying if whatever the I'm getting the value from the current minimum heap, that capital is less than or equal to current capital, means I can do this project. I'm not finalizing this project, but within my budget, within the capital, I should be able to do this one. Okay. Now we will what we will do is we're saying okay, in the profit max heap, we will offer index or offer that profit. Now what will be the profit for that project? We need to find the index of the that capital. So in the simple word, if I separate it, let's say in okay array index, let's say array index will be what? Array index will be current minimum heap. Now as I said that this capital is less than or equal to current capital, so we need to pull the data. So saying, and then we are saying for at that value what is the index? I am saying 1. Now why said 1? Because we are trying to find the array index, and for this array index I is the index, so that is at index 1 0 0, this is 1. So at that time we are saying this is the array index which is at the first index. Now once we found this index, what we'll say is okay, in this one what we need to insert? We need to insert the new integer array, and we will say what is the value of this one. Value of this one nothing but corresponding profit. So profit and array index. This is clear. If it is max sort, you can copy this one and you can put this one inside this one. But to just make it easy to read it, I just separated both the index, both two different lines. Okay. So now what happened? Again, let's repeat this while loop. While loop, what we are doing it, we will go through the minimum heap. We will take the top element or top number, which is the root of that minimum heap. And if we compare, if this is the less than current capital, that means this is within my budget, I should be able to do or not. If yes, then we say okay, tell me the index of that capital. Okay, using that one we found the index of this capital, and then we say we offer the corresponding profit for that index, and as this is within our budget, we have removed from the minimum heap. So this is done. Okay, so once we come out of this loop, we have the max heap ready to decide the project for current capital. So we have max heap ready to decide the project for the current capital. But now we just need to make sure that we found something. Maybe there can be some case that hey, I was not able to do any project within that capital. So we need to just make sure that there is some data is there, it is not empty. If it is empty, we can just break and come out of this one, because we won't be able to do any more project. There is no project which can be done with the current capital. This can be come out of this in first iteration, second iteration, whichever iteration it can come out of this one. We will test that in the test cases. Okay, so we know that okay, profit maximum heap is not empty, and we came here. Now here we need to find the current profit or max profit. Let's say current max profit. Because I say current max profit is that we have the profit max have, so we will do any project which will have the max profit, and in this one we will take from the maximum heap the root element which will have the max profit, and we are saying it the 0th index, because at the 0th index only the one element we inserted this profit max. That's it. Now we count the current profit max. Now we just put the maximum capital, we just do the shortcut sum is equal to current maximum profit. So our maximum capital is become the this one, and I can maintain this one, or let's say instead of this one I put this current capital. I no need to mention this one, and return we can the current capital finally. So I'm removing this one, I don't need this one because we need to maintain the few more variable and we will just assign it. So to avoid that kind of things, I just add the one current capital, and finally we return current capital. So if nothing is, he was not able to select any project, that after that, in that time also he will get at least the current capital. And finally, we just need to increment the I. Okay. So what we are doing, let's check once more time. We are getting the initial capital, we are getting the capital and profits, corresponding profits. So this is like matching the index both. Then we are preparing the minimum heap. Minimum heap we want to prepare based on this comparator. We are saying okay, sort using this definition so that it will be like minimum heap. And then we are offering both value. We are offering the actual value plus index. This index is to get the corresponding profit while we find the capital within that capital some project can be done. Then current capital we initialize with initial capital. Then we started the profit max heap. This is sorted in the reverse order. We want the maximum heap. Then for each project we started checking the profit mix heap, profit maximum heap. We inserted this value, and then finally we just keep adding the maximum profit or current maximum profit, and finally we are returning current profit. Let's test it. We don't know still. We'll test it and then we'll see how it looks. Okay, so in this one what we'll do it, what we need the initial capital, we need the projects, and we need capitals and the profits. So let's simply do it. This one, integer current capital is equal to max capital. What we need initial capital, let's say let's first use the what we used in video. 2 is there, we can do the maximum 2, and here we'll pass the array. One, two, two, 2, 2, 3, and here also we'll pass integer array, and it was 2, 4, 6, 8. Let's print it. So this is again max capital, we can say it, or because okay, let's see. Hope we are not making any mistake. Cool. Okay, so it is expected in our video also we got the final maximum capital as the 11. Now let's see a few more things. Let's say that we want to do 3 projects. We not verified some test cases, but we'll see what is the result it's returning, and then we can just think on that, right? So 17 came. Why 17 came? Okay, so it must have taken the 6th project, one more project, because 8 last time 11 were there, and this time it took the 6th project also. Okay, so this is fine. Now let's change it that hey, this is giving the more profits. Okay, let's just changing the profit. It doesn't matter, but just changing it. Okay, and we are saying it's giving more profit. It's need the more capital also. Okay, 2, 3, 4, 5 is fine. Okay, anything is can be fine. Now what we are saying is he can do maximum 4 project, but his initial capital is 1. Now if you think with initial capital 1, he can't do any project because all the capital is required more than 1. So with this one, our expectation is that the maximum capital should return 1. Why 1? Because this was the current capital. Whatever capital was there, he won't be able to get any profit. This is the expected. Let's see. Cool. So it returned 1 because he cannot earn any profit as he can't do any project. Now something let's do that he can do at least one project. So we are saying he can do 4 project. We are keeping the capital 2. With capital 2 he will get this project and he will earn the profit 4. 4 plus 2 it will become 6. So let's keep all more than 6 so that he can't do more than one project. I'm putting it 7. Okay, so as per this one, so he can do, he initial capital is 2. With initial capital 2 he will do first project, so he will earn the 4 profit, and after the completing one project his capital becomes 6, but within 6 capital he can't do any more project. Even he has allowed to do 4 projects, but due to the capital constraint he won't do it. So with this our expectation is that it should return the 2 initial capital plus 4 he earned 6. Let's see it how to. Cool. So this is how if he can do one co-project, multiple project, this is how it looks, and he can do it the things. Now let's discuss a little bit on time complexity also here only. So what we are doing here is I'm just discussing time complexity here only. We are doing this loop for n time first time. So first our complexity, see we are doing the loop first time, but we are doing priority queue which is sorting the number. So the time complexity of this, let me put in comments so it's okay. So we are doing this one, so time complexity of that one will be big of n log n because we are sorting also, big of n log n. Okay, now second time we are doing this while loop also, and that can go to k time. So for that one, if we do both, it for this one, if you see the time complexity, it will be go of k log n. So if we combine both, what will be time complexity? It will be go of n log n plus k log n. Now in worst case, or not worst case, maybe it's not worst case, but sometimes suppose I have the 5 project. Here we have 4 project and he can do 4 project, all 4 projects. In this case, this second loop also go for the n time. So which means this k can become n. Both are same, I mean, in simple word. So if we simplify this one, then the time complexity of this one like become n plus n log n. Means the final time complexity will become n log n. Right. Now on the space complexity side, we are storing the n number. That is the only maximum. This current minimum heap we are storing n number. Profit maximum heap also it can have the n number. So the space complexity will become big of n. So that's it guys on this video. You can try it from your side, and we'll meet in the next week, next session. Thank you for watching.